today we are going to discuss discrete probability distribution. The first topic is random experiment. The definition of random experiment is it is a well-defined procedure that produces an observable outcome that could not be predicted in advance. Now look the definition of outcome. Outcome is the result of random experiment. We know what is an experiment. Experiment is something which gives outcome. We can classify experiment into two types, that is random experiment and non-random experiment. As we seen that random experiment is an experiment whose outcome cannot be predicted, whereas non-random experiment whose outcome can be predicted. Let us see some examples of random experiment. Tossing of a coin, throwing a die. When we tossing a coin, we can't predict the outcome earlier or in advance. It can be head or tail. When we're throwing a die, we cannot predict the outcome before doing that one. It can be 1, 2, 3. There are 6 phases. So we can't predict the outcome in advance. But coming to non-random experiment, we can predict the outcome before doing that experiment. For example, we know that 2 hydrogen plus 1 oxygen gives water. So we can predict the outcome before doing that experiment. And also salt plus water gives salt solution. Now next is random variable. Random variable is a real valued function defined on the sample space. Or simply we can say that a random variable which quantifies the outcome. Again, random variable can be classified into two, discrete random variable and continuous random variable. Discrete random variable takes finite or countably infinite values, whereas continuous random variable take infinite values. So as I said earlier, a random variable which quantifies the outcome. We can explain random variable by an example. Taking the same example, tossing a coin. We know that when we toss a coin, we got two outcomes. One is head and the other is tail. And the set of all possible outcomes is called sample space. That is, the set of all possible outcomes in an experiment is called sample space, and it is denoted by the letter S. So we can write the sample space of this experiment as S is equal to set of H, T. And we can define a random variable. Let X be the random variable and it be the number of heads. So we can write X is the number of heads. So this is our sample space. Here the outcomes are H and T. Now we denote a random variable X as number of heads. Now X of H, what is X of H? It is equal to 1. In this outcome, number of head equal to 1. Now what about X of T? The number of head equal to, what is number of head? 0. Number of head is equal to 0. So this is x of h equal to 1 and x of t equal to 0. That is 0. I wrote mistakenly as 1. This is 0. Now consider another example, two coins. What is the sample space? HH, TT, TH, HT. Let X is the number of heads. What is XH of 2? XH, it's 2 heads, that is equal to 2 tails, that is equal to 0. 1 head, 1 tail, that is 1. 1 tail, 1 head equal to 1. Now let us take another random variable, y, number of tails. That is XHH equal to 0, XTH equal to 1, that is XTT, that is equal to 1, sorry, that is equal to 2, XHT equal to 1. That's all about random variable and random experiment.